So we're really transitioning in this part of the class. We're kind of moving away from, we worked a lot on exponentials and logarithms and a lot of the pre-calculus algebra type stuff. So in this part of the class, we're going to do a little intro here to ellipses and hyperbolas, and then one more section looking at nonlinear systems, and then from there we move into the trigonometry part of the class. So really changing gears a little bit. So in this section, we're just going to do a brief introduction to ellipses and hyperbolas. So if you worked on these before, maybe in high school, you actually went into a lot more detail than we're going to here. We're just going to kind of get a rough idea of what these shapes look like, make a basic sketch of the graph. So if you look at something like number 1 here, so just think for a second, like what if I were to change something? Like what if I were to make both denominators say 16? Then if I multiplied the whole equation by 16, I'd have this. Isn't that just a circle centered at the origin with a radius of 4? Okay, so this guy looks almost like a circle, but you notice the denominators, the coefficients on the x squared and y squared are different. So this is not a circle, and then that means I actually have a stretch factor. So either the x or y has actually been stretched. So actually this is an oval. We call that an ellipse. Okay, so I have an ellipse. Okay, so I have two options. So I could go about it this way. I could say, let me find the x-intercepts by setting y to 0. So those would be plus and minus 4. Then I could find the y-intercepts by setting x to 0. So that just leaves me the second term. So you can kind of see the second option is, well, if this ellipse is written in this nice standard form where I have x squared over some number squared plus y squared, I'll use n and m, it doesn't matter, equals 1. I can actually read off the x and y intercepts just looking at the numbers underneath those two squared variables. Like here I can tell you the x-intercepts are plus minus 4, the y-intercepts are plus minus 5. But in order to be able to read off that information, I have to have a couple things. I have to have one side equal to 1 here, and then I have to have numbers just underneath the x squared and y squared, not say in front. Okay, but then I can go ahead and graph this. Okay, so let me see. So my x-intercepts, my y-intercepts, try to make this look like an oval. Okay, so it's a stretched circle, but it's not stretched too much since the x-intercepts and y-intercepts are not all that different in magnitude. Okay, so it looks something like that. So let's see here. And then I would call this one, you see how the vertical axis here, the length of that guy's 10 versus the horizontal axis, the length of that guy's only 8. So because the vertical axis here is longer, I would call this a vertical ellipse. Okay, but that's actually all the detail we're going to go into in this class. We're not going to talk about focus points, eccentricity, etc. We just want a rough sketch. So here's another one. Now I know this is an ellipse, again, because I have the plus in the middle here, and because I have different coefficients on the x squared and the y squared. So I know I'm dealing with an ellipse. Okay, but let's see what kind. So I really have two options. I can go ahead and just set x to 0 and y to 0 and find the x and y intercepts. Or I can try to put this in standard form by getting a 1 on the right side. Let me try that. Let's see what happens. So the interesting thing about this one is I end up with this coefficient on the y squared, okay? So that guy is not in the denominator, it's in the numerator. So again, one thought is, well, guess I can just find the x-intercepts. See, if I set y to 0, I'll have x squared over 4 equals 1. So as we expected, those are the easy ones. Those are the 2's. And then the y-intercepts, set x to 0. So you see here I'd have to divide by 4. So these are actually the halves. Okay, so if you want to be able to read that off, you actually have to do an extra step over here, because I need my number in the denominator. So look, isn't dividing by 1/4 the same as multiplying by 4? So then I could actually read off the x and y intercepts, the plus minus 2's, and then the plus minus square root of 4, so halves. And so that's the other idea. Okay, so I don't know how I want to scale this. So since I have that fraction in there, that half, I'll scale this in half. So I'll make that, say, 1, that 2, that 1, that 2. Okay, let me plot the points. Okay, so this ellipse is a little bit more stretched. And then I can see that the horizontal axis is the longer axis. So this is a, oh, I'd already written down here. This is a horizontal ellipse. Okay, so I notice a difference right away here. You see how I have a minus? So this is actually the other shape. So when I have the negative there, this is no longer, where do I want to put this? I guess I can put it here. This is no longer an ellipse. This guy's called a hyperbola. Okay, so I have, we're only looking at basic hyperbolas here. So I have two options. I have a hyperbola like so, or like so. All right, so those are my basic shapes. So again, you can go through and try to find the intercepts again. So look what happens here. If I try to find the x-intercepts, if I set y to 0, this is what I'm left with. So I cannot take the square root of a negative. So I actually have no x-intercepts. So it must mean I have this graph, right? I actually have only y-intercepts. So because I have y-intercepts, I'd call this a vertical hyperbola. Okay, but let me find the y-intercepts. So if I set x to 0, so you see those ones I can read off again. there are those. All right, so I mean, I know roughly my graph's going to be something like that. I just don't know, you know, is it very wide? Is the hyperbola very wide, or is it very narrow, like so? So actually, these hyperbolas have asymptotes. So if you look at these little graphs I drew over here, I actually have asymptotes on here. And those are going to determine how wide or how narrow the graph is. So actually those are really easy to find. So we're not going to go into much detail on why any of this is true, but we're going to just say, okay, look at this. So you see how here I used the 9 already to get the plus minus 3's? I haven't used the 16. So the 16 does not give me any intercepts. However, I still use the 16 and it's going to allow me to find the asymptotes. So here's what I do. I look at the denominators. I use the 9s, square roots of 9s to get the y-intercepts at 3's. Now I'm going to use that 16. So the square root of 16 is 4. So I'm going to go left and right by 4. And then what I'm going to do is I'm going to actually dash in this little rectangle. Okay. And so it turns out that the asymptotes go through the corners of that rectangle. Okay, oops. I'll try to do a very good job on this side. Let's try this side again. Need to go to the corner here and then through the origin. Okay, so then starting at my intercept, then I approach the asymptotes. I have a pretty wide hyperbola here, something like that. And then something like that. Okay, now it's supposed to be symmetric. And so I can actually label the asymptotes as well just by looking at the slope. So let me get rid of this. So if you use that box, that reference box, you can tell, let me see here, would be the equation of this asymptote. Let's see, I have to go, rise is 1, 2, 3, 1, 2, 3, 4. So wouldn't it be 4 over 3, x? Versus like this one here is -1, -2, -3 over 1, 2, 3, 4. Okay. So there are my asymptotes. So if you wanted to write the asymptotes concisely, you could even write this. Did I make a mistake? I think I did. So I'm looking back at the graph here. Look, the rise is 1, 2, 3. The run is 4. I have this upside down. Make sure you fix that. So this guy, the rise is 3. The run is 4. This guy, the rise is -3. The run is 4. There's my nice graph of my hyperbola. Let's do one more of those. So again, this guy's not in standard form because I have this 9 in front. So if I want to be able to read off information, I have to move that 9. It has to be in the denominator. So actually I'd write it like so. Because dividing by a 9th, I flip and multiply, right? So that's the same as multiplying by 9. Okay, so then that means I can actually read off. This one's going to have X-intercepts, right? How do I know? Because this term is positive. So that guy's going to give me solutions, right? Versus this guy's negative. So this guy would have no solutions. Okay, so I can tell just by looking at the signs what kind of hyperbola I'm going to have. This is going to be a horizontal hyperbola. Okay, and I can tell you the x-intercepts. Let's see. The square roots of a 9th, the thirds. No y-intercepts. So then I guess I'll scale this in thirds. So we'll make this, 1. This -1. I'm even thinking, can I extend this? I can keep the scale the same. Okay, so let's see. Okay, so the x-intercepts here and here. And then to draw my box, I have to use those x-intercepts and then the square roots of this number. So those would just be the 1s. Oh, so maybe I don't need more room after all. It's going to be here, huh? For scaling this. So I'm going to draw my box. Let me put my asymptotes in. Okay. Let me put the other one in. All right, something like that, and then starting with the intercept. Okay. Like so. And then let me label the asymptotes. Let's see. So this is for the other problem. Let's get rid of that. So then I have to look at my rectangle. See, so the rise is 3, the run is 1. So this would just be 3x versus this one. The rise is -3, the run is 1. This would be -3x. write the equation of an ellipse with vertices, so x-intercepts plus minus 2, 0, through the given point. Okay, so thinking about an ellipse, gonna have something like this, right? Okay, I know the x-intercepts. So this guy here has to be a 4, right? So all I have to do is find this number here. So let me pick a variable, I don't know, p. And let me figure out what p is. So what I'm gonna do is, I'm gonna plug in this point. Okay, so the x is 1. The y is negative 3/2. Okay, so that's 1 over 4. It's 9/4 over p equals 1. From there I have a couple ideas. I don't know, let me subtract the 4th. That's going to be 3/4. And then let me multiply up the p. Multiply by 4. So p is 3. Look at that. Write the equation of the hyperbola with intercepts. So hyperbola, let's see, so this guy has x-intercepts. So if it has x-intercepts, then the x squared is the positive term. If it would have had y-intercepts, I would have set it up like this. Okay, this guy's a horizontal hyperbola, so the x term is going to be positive coefficient. So this is going to be what, 36? Solve for p again. Okay, so let me plug these values in. Let's see, 9 squared. Oops. I don't know, multiply by 36p. I have a couple ideas, so let's see if I do that. 36 will cancel, I'll have 81p. And then here, the p will cancel, the heck is 25 times 36. $900. Interesting. The numbers are a little big in this one. Okay, multiply here as well. Okay, then what is 81 minus 36? 45? So, oh, it comes out nice, huh? Divide by 45? Negative 45? Okay, 90 divided by 45 is 2, so that's 20.